Hi, my name is Shannon, and today I'll be talking about what Euler's method is, how to solve initial value problem using Excel spreadsheet, and the approximation error from Euler's method. Euler's method works for solving first-order ordinary differential equation, which is the dy dx. Let's say, for example, a question gives only f_pi and the initial value x0, y0, and they want us to find x1. They want us to find y when x equals to 1. How should we find it? So Euler's method is basically a method to approximate a solution, and when we cannot separate or differentiate a differential equation easily. So we can draw a tangent line over here to approximate another point on the curve, which is this one here. Can find another point on this tangent line, which is, for example, over here, which creates a step size h, or the change in x. Change in x is also h, which is the step size. This allows us to find another point on the curve. However, this approximated point is obviously not the same as the actual point on the curve, so thus there will be an approximation error, which I will be talking about later. MVP using Excel spreadsheet. Given dy dx equals to x over y squared and y0 equals to 1, find the approximate value of y1. So in my Excel spreadsheet, I assume that my step size h equals to 0.1. My general formula is the same as yn plus 1 equals to yn plus h f_pi xn, yn. My h is the step size. So over here, the question also gives that f_pi equals to dy dx, which equals to x over y squared. So my initial values are given that x equals to 0 and y equals to 1 over here. So how I find the x value is that I use the initial value plus the step size 0.1. So the initial value plus step size 0.1 is 0.1, and from this value now plus 0.1, it'll be 0.2, and so on until I reach x equals to 1, which is what I'm finding. So now to find y, I plug in the values into the general formula. So my y will be 1 plus my step size 0.1 times f_pi, which is x over y squared, so 0 over 1 square. And this answer will be my answer over here, which is E4. This answer is here. And I did the same for the rest also. This answer is this answer here, and so on, until when the x equals to 1, my y equals to approximately 1.33931. Approximation error from Euler's method. So finding the actual answer given in the question dy dx equals to x over y squared, I can solve it by solving how I solve separable ODE, by bringing all the y's to the left side and all the x to the right side, and integrate them both to get y equals to cube root 3x squared over 2 plus c. And I can find c, which is subbing in y equals to 1 and x equals to 0 given in the question. My c is 1, and therefore my y equals to cube root 3x squared over 2 plus 1. Then I can find x equals to 0.1, my y will be 1.004, and my x equals to 0.2, my y will be 1.019, and so on until my x equals to 1 and my y equals to 1.357. Then I can compare my answers from the Excel spreadsheet, which is the approximate answers, and my actual answers that I calculated just now. And since they are quite close to each other, we can say that the Euler's method is a good approximation. Thank you.